Welcome to Math with Mr. J. In this video, I'm going to cover compound inequalities. We will go through graphing compound inequalities on a number line, writing compound inequalities from a number line, solving compound inequalities, and then lastly, we will put solving and graphing together, where we will solve and graph compound inequalities. Everything is put into sections and time-stamped, so feel free to jump around. We will start with graphing compound inequalities on a number line. Now for numbers 1 and 2, we will break everything down along the way in order to better understand everything. We will start with an OR compound inequality, then move on to an AND compound inequality, and then lastly, we will end with numbers 3 and 4. Let's jump into number 1, where we have x is less than or equal to 0, or x is greater than 4. So here, x has to be less than or equal to 0, or x has to be greater than 4. So a solution of a compound inequality involving OR is anything that makes either inequality true. So basically, this must be true, or that must be true. Now let's graph this compound inequality on a number line to give us a nice visual representation. And we're actually going to break this down into two graphs first in order to better understand what we're working with here. Then we will combine everything into one. Let's start with x is less than or equal to 0, and just focus on that. Now 0 is included, so we need a filled circle at 0, and then an arrow going left representing everything less than 0. So 0 is a solution and anything less than 0. Next, we have x is greater than 4. So we need an open circle at 4. 4 is not included. And then we need an arrow going right representing everything greater than 4. And that's x is greater than 4. Anything greater than 4 is a solution. Now, since this is a compound inequality, we need to combine these. We're going to graph them on the same number line. So we have x is less than or equal to 0. So we need that filled circle at 0 with the arrow going left. And then we have x is greater than 4. So we need that open circle with the arrow going right. So this is our graph of the compound inequality. This represents x is less than or equal to 0, or x is greater than 4. So as far as solutions, some numbers that will work for x and make this compound inequality true, let's try a couple of numbers out. For example, will 2 work for x? Is 2 a solution? Well, is 2 less than or equal to 0 or greater than 4? No, so 2 is not a solution. How about 7? Is 7 less than or equal to 0 or greater than 4? Yes, 7 is greater than 4, so 7 is a solution. Anything less than or equal to 0 will work, or anything greater than 4 will work. And we can see that represented on the number line. Let's move on to number 2, where we will have an AND compound inequality. Let's jump into number 2, where we have x is greater than -2 and x is less than or equal to 7. So we have two inequalities combined by AND. So here, x has to be greater than -2 and less than or equal to 7. So a solution of a compound inequality involving AND must make both inequalities true, must satisfy both. Now, something I want to mention about compound inequalities involving AND, they can be written without the word AND in the middle. All we need to do here is start with our variable, x. And our variable is going to go in the middle. Now, x is greater than -2, and x is less than or equal to 7. And that's our compound inequality written without the word and. And we can read this starting with the variable. So x is greater than -2 and less than or equal to 7. So whenever you see a compound inequality written like this, it's a compound inequality involving and. So this is something to keep in mind while working with compound inequalities. Now let's graph this on a number line, and this is going to give us a nice visual representation of the compound inequality. And we're going to break this down into two graphs first in order to better understand what we're working with here. And then we will combine everything into one. First, we have x is greater than -2. So let's just focus on that and graph that. -2 is not included, so we start with an open circle at -2. And then we need an arrow going right, representing everything greater than -2. And that's x is greater than -2. Anything greater than -2 is a solution. Next, we have x is less than or equal to 7. Now, 7 is included, so we need a filled circle at 7 and then an arrow going left representing everything less than 7. And that's x is less than or equal to 7. 7 is a solution and anything less than 7. Now, since this is a compound inequality, we need to combine these. We need to see where they overlap. So think of it like this. We want this section right here. So we need an open circle at -2, a filled circle at 7, and then we want everything in between. So this is our graph of x is greater than -2 and less than or equal to 7. That represents our compound inequality. So as far as solutions, some numbers that will work for x and make this compound inequality true, let's try a couple of numbers out. For example, will 3 work for x? Is 3 a solution? Well, is 3 greater than -2 and less than or equal to 7? Yes, so 3 is a solution. How about 10? Is 10 greater than -2 and less than or equal to 7? Well, 10 is greater than -2, but 10 is not less than or equal to 7. So 10 is not a solution. So anything greater than -2 and less than or equal to 7 will work. And we can see that represented on the number line. Let's move on to numbers 3 and 4. Here are numbers 3 and 4. And for these, we're going to graph everything right from the compound inequality. We're not going to break it down into two separate graphs like we did for numbers 1 and 2. And feel free to pause the video and try these on your own if you would like. Let's jump into number 3, where we have y is less than -3 or y is greater than 1. Let's start with y is less than -3. We need an open circle at -3. -3 is not included. And then we need an arrow going left representing everything less than -3. Now we need y is greater than 1. So we need an open circle at 1. 1 is not included. And then an arrow going right representing everything greater than 1. And that's it. That's our graph on a number line of y is less than -3 or y is greater than 1. Let's move on to number 4, where we have d is greater than or equal to 24 and less than or equal to 30. So this is an and compound inequality. Remember, when we have a compound inequality involving and, it can be written without and. Let's start with d is greater than or equal to 24. Now 24 is included, so we need a filled circle at 24. And D is less than or equal to 30. So let's put a filled circle at 30 as well. 30 is included. So we need everything greater than or equal to 24 and less than or equal to 30. So we want everything in between here. And that's it. That's our graph on a number line of D is greater than or equal to 24 and less than or equal to 30. So there's our section on graphing compound inequalities on a number line. Let's move on to writing compound inequalities from a number line. Here's our section on writing compound inequalities from a number line. Let's jump into number 1. Now, the first thing that we need to determine when writing a compound inequality from a number line is if it's an or and compound inequality. Well, we can see that we have two separate inequalities graphed here with that gap in the middle, and the arrows are going in opposite directions. So this is going to be an or compound inequality. We can clearly see we have two inequalities here. We have this inequality or this inequality. Now, taking a look at the inequality on the left, we have an open circle at -2. So -2 is not included. Then the arrow is going left. So that's representing everything less than -2. Let's use x for our variable. So we have x is less than -2. Now, the inequality on the right, we have a closed circle at 1. So 1 is included. Then we have an arrow going right, representing everything greater than 1. So we have x is greater than or equal to 1. And those are our two inequalities that make up our compound inequality. So let's write this out using or. We have x is less than -2 or x is greater than or equal to 1. And that's it. We're done. That's our compound inequality from the number line below. Let's move on to number 2. Now let's take a look at number 2 and start by seeing if this is an or and compound inequality. Well, we have what looks like a line segment or just a section of a number line here. We don't have any arrows or inequalities that necessarily pop out, so to speak. This is what and compound inequalities look like on a number line. Now we can see that we have a filled circle at 2. 2 is included. Then we have the numbers to the right, so greater than 2. So we have 2 included here, and then we want the numbers to the right. So our inequality here, and we will use x for our variable, is x is greater than or equal to 2. Next, we have an open circle at 9. So 9 is not included. Then we have the numbers to the left. So less than 9. So an open circle at 9. And then the numbers to the left. So our inequality here is x is less than 9. And these are our two inequalities that make up our compound inequality. And since this is an and compound inequality, we want where these two inequalities overlap. X has to be greater than or equal to 2 and less than 9. So let's write this out. X is greater than or equal to 2 and x is less than 9. Now remember, we can write and compound inequalities without the word and. So we can write this as x. I like to write the variable down first, and it goes in the middle, is greater than or equal to 2 and less than 9. So again, x is greater than or equal to 2 and less than 9. And that's our compound inequality written out from the number line. Let's move on to numbers 3 and 4. Here are numbers 3 and 4. Feel free to pause the video and try these two on your own if you'd like. Let's jump into number 3, and it looks like we have an OR compound inequality. We have a filled circle at 20. 20 is included. Then the arrow is going left, representing everything less than 20. So we have x is less than or equal to 20. Then we have a filled circle at 25 with an arrow going right representing everything greater than 25. So we have x is greater than or equal to 25. Now we have our two inequalities that make up our compound inequality. We have x is less than or equal to 20, or x is greater than or equal to 25. Let's move on to number 4, and it looks like we have an and compound inequality here. We have an open circle at -3, a filled circle at +3, and then we want everything in between. So where our two inequalities overlap. Let's figure out our two inequalities. We'll start with -3. We have an open circle there. So -3 is not included. Then we have the numbers to the right. So greater than -3. So an open circle at -3. And then we want the numbers greater than -3. So our inequality here, x is greater than -3. Next, we have a filled circle at +3. 3 is included. Then we have the numbers to the left, so less than 3. So 3 is included here. And then we want the numbers less than 3. So our inequality, x is less than or equal to 3. And those are our two inequalities that make up our compound inequality. And since this is an and compound inequality, we want where these two inequalities overlap. X has to be greater than -3 and less than or equal to 3, +3. So let's write this out using and then without and. So we have x is greater than -3 and x is less than or equal to 3, +3. Now let's write this without and. So we have x is greater than -3 and less than or equal to 3. So x is greater than -3 and less than or equal to 3. Now let's move on to solving compound inequalities. Here is our section on solving compound inequalities. We'll go through 4 examples. 2 examples of compound inequalities involving OR, and 2 examples of compound inequalities involving AND. We will start with OR and then move on to AND. Let's jump into number 1, where we have 6y is less than 30, or 4y plus 10 is greater than 54. Now, when we solve a compound inequality involving OR, all we need to do is solve each inequality separately. So we need to solve 6y is less than 30. Then we need to solve 4y plus 10 is greater than 54. Let's start with 6y is less than 30. We need to isolate that variable of y. Y is being multiplied by 6, so we need the inverse operation of multiplication. That's division. So let's divide the left side by 6. Now remember, whatever we do to one side of an inequality, we must do to the other. So we need to divide the right side by 6 as well. Now the 6's on the left side cancel each other out. So y is now isolated. Y is less than. And then on the right, 30 divided by 6 gives us 5. So we have y is less than 5. Now let's solve 4y plus 10 is greater than 54. We have multiplication and addition, so we need to undo the addition first. The inverse operation is subtraction. So let's subtract 10 from the left side and the right side as well. Now the 10's on the left cancel each other out. So we have 4y is greater than, and then on the right side, 54 minus 10 gives us 44. So we have 4y is greater than 44. So y is being multiplied by 4. We need the inverse operation of multiplication. That's division. So divide the left side by 4. We need to divide the right side by 4 as well. The 4's on the left cancel each other out. Y is now isolated. We have y is greater than, and then on the right, 44 divided by 4 gives us 11. So we have y is greater than 11. And now we're done solving our two inequalities. So let's rewrite this as a compound inequality involving or. So we have y is less than 5 or y is greater than 11. So again, we have y is less than 5 or y is greater than 11. Now remember, when it comes to compound inequalities involving or, they are true, we have a solution, if either inequality is true. That means that y can be anything less than 5 or y can be anything greater than 11. Any number less than 5 or greater than 11 is a solution of this compound inequality. It will make the compound inequality true. Let's move on to number 2. Now let's take a look at number 2, where we have x plus 5 is less than 3. Or negative 2x minus 4 is less than or equal to negative 18. So remember, we need to solve these separately. So we have x plus 5 is less than 3. And then we need to solve negative 2x minus 4 is less than or equal to negative 18. Let's start with x plus 5 is less than 3. So we need to isolate x here and undo that addition. The inverse operation of addition is subtraction. So we need to subtract 5 from the left side. That means we need to subtract 5 from the right side as well. The 5's on the left cancel each other out. X is now isolated, so we have x is less than, and then on the right side, 3 minus 5 gives us negative 2. So we have x is less than negative 2. Now we need to solve negative 2x minus 4 is less than or equal to negative 18. We need to undo the subtraction first. The inverse operation of subtraction is addition, so we need to add 4 to the left side. That means we need to add 4 to the right side as well. So the 4's on the left cancel each other out. We have negative 2x is less than or equal to. And then on the right, negative 18 plus 4 gives us negative 14. So now we have negative 2x is less than or equal to negative 14. Let's undo that multiplication with the inverse operation, division. So we need to divide the left side by negative 2. That means we need to divide the right side by negative 2 as well. And remember, when we divide or multiply both sides of an inequality by a negative, the inequality symbol flips. So these negative 2's cancel each other out. We have x the inequality symbol flips. So we have x is greater than or equal to. And then on the right side, negative 14 divided by negative 2 gives us 7, a positive 7. Remember, a negative divided by a negative equals a positive. So x is greater than or equal to 7. And now we are done solving our two inequalities. And we can rewrite everything as a compound inequality. So we have x is less than negative 2, or x is greater than or equal to 7. So again, x is less than negative 2, or x is greater than or equal to 7. Any number less than negative 2 or greater than or equal to 7 is a solution of this compound inequality. It will make it true. Let's move on to numbers 3 and 4, where we will have compound inequalities involving and. Taking a look at number 3, which is an and compound inequality, we have x minus 6 is greater than or equal to 0 and less than or equal to 11. In other words, x minus 6 has to be greater than or equal to 0, and x minus 6 has to be less than or equal to 11. Now, when it comes to solving compound inequalities involving and, we have two ways we can do it. We can solve each inequality separately or at the same time. I'll go through both ways, and you can use what works best for you. Let's start by separating this into the two inequalities that make up the compound inequality. This way helps us break everything down and helps us understand a little more. And it can help us stay a little more organized. So we have 0 is less than or equal to x minus 6, and x minus 6 is less than or equal to 11. So those are the two inequalities that we need to solve. Let's start with 0 is less than or equal to x minus 6. Well, we need to isolate x. We have x minus 6, so we need the inverse operation of subtraction. That's addition. So let's add 6 to the right side of the inequality. Whatever we do to one side, we must do to the other. So let's add 6 to the left side as well. Now the 6's on the right cancel each other out. X is now isolated, so we have x is greater than or equal to, and then on the left side, 0 plus 6 gives us 6. So we end up with 6 is less than or equal to x if we are reading this from left to right. Or we can also say x is greater than or equal to 6. So thinking about it and reading it with the variable coming first. And we can even write it out that way if it helps. So x is greater than or equal to 6. Now we need to solve x minus 6 is less than or equal to 11. Let's isolate x. So we need to add 6 to the left side. That means we need to add 6 to the right side as well. Now the 6's on the left cancel each other out. X is now isolated. So x is less than or equal to, and then on the right, 11 plus 6 gives us 17. So we have x is less than or equal to 17. And now we're done solving our two inequalities. X has to be greater than or equal to 6, and x has to be less than or equal to 17. Now we can combine these and write this compound inequality without the word and. So we have x is greater than or equal to 6 and less than or equal to 17. So x has to be greater than or equal to 6, and x has to be less than or equal to 17. X has to be both. X has to satisfy both. Remember, a solution of a compound inequality involving and is any number that makes both inequalities true. It has to work for both. Now let's solve this a second way, and for this, let's rewrite it over here so we have x minus 6 is greater than or equal to 0 and less than or equal to 11. Now here, we're going to solve both inequalities at the same time and solve from the compound inequality written like this. We're not going to separate it with the word and. So let's isolate the variable. We're subtracting 6. So we need to undo that with the inverse operation, addition. Let's add 6 here in the middle. That means we need to add 6 over here on the left and add 6 over here on the right. Now the 6's in the middle cancel each other out. So x is now isolated. We have x is greater than or equal to, on the left, 0 plus 6 gives us 6. And then x is less than or equal to, and then on the right, we have 11 plus 6 is 17. So we end up with x is greater than or equal to 6 and less than or equal to 17. So we get the same thing here. And really, we solved it the same way. We just didn't separate it. Let's move on to number 4. Now let's take a look at number 4. And we're going to solve this the same way we did number 3. We're going to solve each inequality separately, then at the same time. So let's jump into number 2 here, where we have 3m plus 7 is greater than or equal to negative 2 and less than 13. Let's start by separating this into the two inequalities that make up the compound inequality and solving each of those. So we have negative 2 is less than or equal to 3m plus 7. And then we will solve 3m plus 7 is less than 13. Now, as far as negative 2 is less than or equal to 3m plus 7, we need to isolate m here. We have multiplication and addition. We need to undo the addition first using the inverse operation, subtraction. So let's subtract 7 from the right side. That means we need to subtract 7 from the left side as well. Now the 7's on the right cancel each other out. So we have 3m is greater than or equal to, and then on the left, negative 2 minus 7 gives us negative 9. So we have negative 9 is less than or equal to 3m. So we need to undo that multiplication by using the inverse operation, division. So divide the right side by 3. That means we need to divide the left side by 3 as well. Now the 3's on the right cancel each other out. M is now isolated. So we have m is greater than or equal to, and then on the left, negative 9 divided by 3 gives us negative 3. So we end up with negative 3 is less than or equal to m if we are reading this from left to right. Or we can also say that m is greater than or equal to negative 3. So thinking about it and reading it with the variable coming first. Now we need to solve 3m plus 7 is less than 13. So we need to undo that addition first by subtracting 7 from the left side. And then we need to subtract 7 from the right side as well. These 7's cancel each other out. So we have 3m is less than, and then on the right, 13 minus 7 gives us 6. So we have 3m is less than 6. We need to undo the multiplication using division. So divide the left by 3 and then the right by 3. The 3's on the left cancel each other out. So m is now isolated. M is less than, and then on the right, 6 divided by 3 is 2. So we end up with m is less than 2. So m has to be greater than or equal to negative 3 and m has to be less than 2. And now we can combine these and write this compound inequality without and. So we have m is greater than or equal to -3 and less than 2. So m has to be greater than or equal to -3, and m has to be less than 2. Now let's solve this the other way, and we will solve them at the same time without separating the compound inequality. So let me rewrite it over here. So now we need to isolate that variable of m. Again, we have multiplication and addition here. So we need to undo the addition first. So let's subtract 7 from the middle. That means we need to subtract 7 from the left and the right as well. Now the 7's in the middle cancel each other out. So we just have 3m. And then as far as the left, -2 minus 7 gives us -9. And then on the right, 13 minus 7 gives us 6. So now we have 3m is greater than or equal to -9 and less than 6. So we need to undo that multiplication using the inverse operation, division. So divide by 3 here. And then we need to divide the left by 3 and the right by 3. These 3's cancel each other out. M is now isolated. On the left, -9 divided by 3 gives us -3. And then on the right, 6 divided by 3 gives us 2. So we end up with m is greater than or equal to -3 and less than 2. So we can see that we get the same thing that way as well. Now let's move on to our section on solving and graphing compound inequalities. Here's our section on solving and graphing. We'll go through 2 examples. We'll start with a compound inequality involving or, and then move on to a compound inequality involving and. Let's jump into number 1, where we have -5w minus 2 over 8 is greater than -4, or 2w plus 6 is greater than 30. Now, when we solve a compound inequality involving or, all we need to do is solve each inequality separately. So we need to solve -5w minus 2 over 8 is greater than -4. And then we need to solve 2w plus 6 is greater than 30. Once we solve, we can graph the solutions on a number line. Let's start by solving -5w minus 2 over 8 is greater than -4. So we need to isolate that variable of w. We need to start by undoing the division, dividing by 8. The inverse operation of division is multiplication. So let's multiply the left side by 8. That means we need to multiply the right side by 8 as well. Now the 8's on the left cancel each other out. So we have -5w minus 2 is greater than, and then on the right, -4 times 8 gives us -32. Now we have -5w minus 2 is greater than -32. We have multiplication and subtraction here. So we need to undo the subtraction next. The inverse operation is addition. So add 2 to the left side and the right side. The 2's on the left cancel each other out. So we have -5w is greater than, and then on the right, -32 plus 2 gives us -30. So now we have -5w is greater than -30. So we have multiplication. The inverse operation of multiplication is division. So we need to divide the left side by -5 and then the right side by -5 as well. Now remember, when solving inequalities, when we divide or multiply both sides by a negative, the inequality symbol flips. So on the left, these negative 5s cancel each other out. W is now isolated. The inequality symbol has flipped. And then on the right, negative 30 divided by negative 5 gives us 6, a positive 6. Remember, a negative divided by a negative gives us a positive. So we have W is less than 6, or, and now we need to solve 2W plus 6 is greater than 30. So we have multiplication and addition here. We need to undo the addition first using the inverse operation, subtraction. So subtract 6 from the left side. That means we need to subtract 6 from the right side as well. Now the 6's on the left cancel each other out. So we have 2W is greater than, and then on the right, 30 minus 6 gives us 24. So now we have 2W is greater than 24. So we need to undo that multiplication using the inverse operation, division. So divide the left by 2, and then the right by 2 as well. The 2's on the left cancel each other out, so W is now isolated. W is greater than, and then on the right, 24 divided by 2 gives us 12. So W is greater than 12. Now we have both of our inequalities solved, and we can bring this down here and write this as a compound inequality. We have W is less than 6, or W is greater than 12. So W can be anything less than 6 or greater than 12. Any number less than 6 or greater than 12 is a solution of this compound inequality. It will make it true. Now let's graph this on a number line to represent this. We will go from 5 to 13, one number to the left of 6 and to the right of 12. So let's draw out the number line. And we have 5, 6, 7, 8, 9, 10, 11, 12, 13. 5, 6, 7, 8, 9, 10, 11, 12, 13. Now let's start with W is less than 6 as far as graphing on the number line. Now 6 is not included, so we need an open circle at 6 with an arrow going left representing everything less than 6. So that's W is less than 6. Now we need W is greater than 12. 12 is not included, so we need an open circle at 12 with an arrow going right representing everything greater than 12. And that's W is greater than 12. We are done. That's W is less than 6 or W is greater than 12 graphed on a number line. Let's move on to number 2. Taking a look at number 2, which is an and compound inequality, we have 4c minus 5 is greater than or equal to negative 9 and less than 7. Now, when we solve a compound inequality involving and, we can solve everything all at once, meaning we can solve both of the inequalities that make up the compound inequality at the same time. And then once we solve, we can graph the solutions on a number line. Let's start by rewriting the compound inequality, and we will solve from this. We need to look to isolate that variable of c. We have multiplication and subtraction, 4c minus 5. So we need to undo the subtraction first. The inverse operation is addition. So let's add 5 to the middle. That means we need to add 5 to the other parts of the compound inequality as well. So add 5 to the left and to the right. Now the 5's in the middle cancel each other out. So we have 4c is greater than or equal to, and then on the left, negative 9 plus 5 gives us -4, and then 4c is less than, and then on the right, 7 plus 5 gives us 12. So now we have 4c is greater than or equal to -4 and less than 12. We need to undo the multiplication using the inverse operation, division. So divide the middle by 4. That means we need to divide the left and right by 4 as well. Now the 4's in the middle cancel each other out, so c is now isolated. C is greater than or equal to. On the left, -4 divided by 4 gives us -1. And C is less than. And then on the right, 12 divided by 4 gives us 3. So C is greater than or equal to -1 and less than 3. In other words, C has to be greater than or equal to -1 and less than 3. So C has to work for both, satisfy both. Now let's graph this on a number line. And we will go from -2 to 4, one number to the left of -1, and to the right of 3. So here is our number line. And we will go from -2 to 4. So -2, -1, 0, 1, 2, 3, 4. -2, -1, 0, 1, 2, 3, 4. Now we want everything greater than or equal to -1. So -1 is included. We need a filled circle at -1 to show that. And we need everything less than 3. 3 is not included. So we need an open circle at 3. Again, we want greater than or equal to -1 and less than 3. So we want where these two inequalities overlap. So we want in between here. And that C is greater than or equal to -1 and less than 3 graphed on a number line. So there you have it. There's how to graph, write, and solve compound inequalities. I hope that helped. Thanks so much for watching. Until next time, peace.